Have you ever just looked up at the moon and wondered, why is it just hanging up there? I mean, it's a question that feels so basic, right? But it actually unlocks one of the biggest secrets about how our whole universe works. We all know gravity pulls everything down, so what's so special about the moon?
We've all heard the story about Isaac Newton and the apple. He's sitting there, sees it fall, and boom, this revolutionary idea about a universal force of gravity just clicks. But that leads to an even bigger puzzle. If that exact same force that yanks an apple to the ground is also pulling on the moon, well, why isn't the moon crashing down on our heads?
And here's the answer, the twist that changes everything. The whole question is based on the wrong idea. The moon is falling. Right now, this very second, it is plummeting towards the Earth. So the real question we should be asking isn't why doesn't it fall, it's how in the world does it keep missing?
The answer is this perfect cosmic balancing act. Just picture two massive forces in a constant game of tug-of-war. On one side, you've got Earth's gravity, relentlessly pulling the moon in. But on the other side, the moon has this incredible forward momentum, a sideways speed that's always trying to fling it in a straight line out into deep space. An orbit is the perfect stalemate in that battle.
And just how fast is that sideways speed we're talking about? Get this, it's about 3,600 kilometers per hour. That's roughly a kilometer every single second. It's that mind-boggling velocity that lets the moon constantly move forward just enough to cancel out gravity's downward pull. So yeah, it's falling, but it's also moving sideways so fast that it just never gets any closer.
To really wrap your head around this, Isaac Newton came up with this absolutely brilliant thought experiment. He told us to imagine a mountain so tall it actually pokes out above Earth's atmosphere, and on top of it, a giant cannon. This simple idea explains an orbit perfectly.
Okay, so let's walk through it. You fire the cannon with just a little bit of gunpowder. The cannonball travels a short distance, and gravity pulls it right back down to the ground. Simple enough? Now, let's fire it faster. It travels way farther, but still, gravity eventually wins and it smacks into the Earth. But what happens if you fire it at just the right incredible speed? The cannonball is still falling, but because it's moving forward so fast, the very surface of the Earth is curving away from it at the exact same rate. It falls and falls and falls, but it never, ever lands. It's in orbit. And that is exactly what the moon is. It's Newton's final cannonball. Its sideways speed is so perfectly tuned to Earth's gravity that it's just in a state of continuous freefall, forever missing the planet. To put it simply, the moon doesn't fall onto Earth because it's always falling around Earth. And hey, this isn't just about the moon. This exact same principle is what keeps our entire modern world running. All those thousands of satellites for GPS and your phone signal, and even the International Space Station. They're all constantly falling towards Earth, but they're moving sideways so incredibly fast that they, and the astronauts inside, just stay in this perfect, continuous orbit. So this leads to a pretty logical question, doesn't it? If this is all just a super delicate balance, is it going to last forever? Could the moon, eventually lose some of that sideways speed, get snagged by gravity, and finally come crashing down on us way, way in the future?
And the answer to that is one of the most surprising facts about our little piece of the solar system. Not only is the moon not going to fall into the Earth, something completely different and frankly kind of wild is going on.
Believe it or not, the moon is actually getting farther away from us. Because of some really complex tidal interactions between the planet and the moon, it's slowly drifting away from us at about 3.8 centimeters every single year. Yeah, that's about the same speed your fingernails grow. So, no chance of a collision. In fact, it's slowly saying goodbye.
So after all that, what have we really learned an orbit is? It's got nothing to do with floating or defying gravity. It's the result of gravity. It is the state of continuously falling towards something, but moving sideways just fast enough to constantly and perfectly miss it.
So in the end, it all comes down to a really simple but powerful idea. An orbit isn't magic. It's just the result of two things we can all understand: falling down and moving forward really, really fast. And when you combine them in just the right way, you don't get a crash. You get a beautiful, stable orbit. You get our moon.